So we're looking at solving quadratic equations, and what we mean by solving quadratic equations is finding whenever we have a quadratic equation being a parabola, where it hits the x-axis, because our x-axis or our x-intercepts are going to be the solutions, or what we get when we're looking for when we solve the quadratic equations. So it's our x-intercepts. Now we have some options to what that could be. So most typically, the ones we see have two solutions. So like the one we have here in the top right, or top left, it hits at 2 points, so those 2 points would be our two solutions. It is possible though to have a one solution, and that would be when your vertex, and the vertex of the parabola is on the actual x-axis. And then the other one we could have, which really doesn't help us a whole lot right now, is when you have no solutions, and that one would be when it doesn't hit the x-axis at all. So that'd be zero solutions or no solutions. So what we're going to do is we're going to get different quadratic equations, and we're going to solve them to find out if we have two solutions, one solution, or no solution. And eventually we're going to use those in conjunction with finding the vertex to look at starting to graph different parabolas. So let's say we have something like x squared minus 16 equals 0. If I went to graph that by what we've talked about and looked at so far, and I just said, well, let's let y equal x squared minus 16, that would be a graph that would be way down here at negative 16 and be going up from that, and we could keep plotting points to try to figure out to when it hits the x-axis, or look at this and say, well, when am I going to get that x squared minus 16 comes out to be 0 in this case, and we hopefully see 4 and negative 4 would be solutions. And we can even take the equation to use that, and if we said, well, x squared minus 16 equals 0, x squared equals 16 by taking the square root of both sides. Since it could be a positive or negative squared, we're going to write plus or minus the square root of 16. So x equals plus or minus 4. And our solutions are 4 and negative 4. We do that whenever we have a square root, because we could square it and it could be positive or it could be negative. And this is how we get those two solutions. On this parabola, it does in fact hit at 4 and negative 4, and those are the two solutions we'd use. Let's look at a different one. And what if we had 3x squared plus 6 equals 0? If I subtract over the 6, I get negative 6. If I divide by 3, I get negative 6 over 3, or just negative 2. Now when I go to take the square root of both sides, we have the square root of negative 2. Now it's not possible to get a number times itself to come out to be a negative. So whenever we get the square root of a negative, it's not possible. We're going to write no solution. And this would be a graph where it wouldn't hit the x-axis at all. And if I go back and graph this on what we've done earlier, the fact it's 3x squared plus 6 means we'd go up and start with an y-intercept at 6 and open up, and it does in fact never hit the x-axis. So let's look at a few more, and we'll kind of work our way through and find the different ways we can find the number of solutions. It's really not so much graphing, but more using some algebra. If I get x squared minus 25 equals negative 25, you're going to get the x by itself by adding 25 to the other side. You get x squared equals 0. If I take the square root of both sides, I do plus or minus the square root of 0. Well, we get x equals a 0. This would be a parabola that would have one solution, and that solution is x equals 0. Let's look at x squared minus 36 equals 0. If we add the 36 over, x squared equals 36. We take the square root of both sides. I get x on the left side and a plus or minus 6 on the right side. So my two solutions are 6 and negative 6. And if you're wondering why do we have to have the plus or minus, because if I worked my way backwards, and if I did 6 squared, that would come out to be a 36. And if I did negative 6 squared, negative 6 times negative 6 is a positive 36, it would also be one that works. Let's look at 3x squared plus 15 equals 0. If I subtract over the 15, and then I divide by 3, I have x squared equals negative 5. Now looking at this, I'm going to take the square root of both sides, but hopefully we see in taking the square root of a negative, it's not going to work, so we write no solutions. Does not hit the x-axis. Don't need to write a number, you just write no solutions. Don't write the negative. Let's do 4x squared plus 16 equals 16. I'm going to do 4x squared, subtract the 16 over, I get 0. Divide both sides by 4. Square root of both sides, I get x equals 0, and that is my one solution. Let's go look at 2x squared now, minus 32 equals 0. I add over the 32, I get 2x squared equals 32. Divide both sides by 2, x squared equals 16. We're going to take the square root of both sides. Make sure you put a plus or minus there. So it comes out to be x equals plus or minus 4, or x equals 4 and negative 4, and we have two solutions there. So let's just kind of generalize to what we've already seen. So if we solve it down, so after getting x by itself, or x squared we should say, so x squared equals something. If it's equal to a positive, we're likely going to have a plus or minus and two solutions. Now, maybe they're not a perfect square, maybe it's going to be left in radical form, that's fine, but at least it works, we get a two solutions. If it comes out and it equals 0, well, that means we're just going to have one solution, and it's likely going to be 0. If it comes out to be a negative, well, that means we're going to have no solutions, because you can't take the square root of a negative. We'll say no solutions. And what you have to be careful with here is in the second one, we're saying you actually get 0 as a solution. And in the third one, you're saying you get no solutions, 0 not being one of them. None of them work. So all of these, depending where you have for x squared, is going to indicate where it'll finish, and it just depends on what values you have from there. Let's finish with one last problem, and let's look at if we had a triangle, and in that triangle both the base and the height were the same, so we're just going to label them both h, and your area is 20 feet squared. So we know, hopefully, that the area of a triangle is 1/2 base times height. So I'm going to say 20 is equal to 1/2 h times h, because they're both the same value. So we're going to go 20 equals 1/2 h squared. I then multiply over with the 1/2, or multiply both sides by 2, and I get 40 equals h squared. I'm going to take the square root of both sides, and it is a positive, so I do get a result. I actually get two solutions. I get plus or minus the square root of 40. Now, whether you remember this or not, we can simplify a radical here, because it is 4 times 10, and 4 is the two 2's. So this is actually plus or minus 2 root 10. Now, we can also approximate. We know square root of 40 is in between 6 and 7 because square root of 36 is 6, square root of 49 is 7. It's actually about 6.3. So let's just, for the sake of this problem, say it's about plus or minus 6.32. Now, do we actually have two solutions to this problem? In solving it, yes, we get plus or minus 6.32, but to fit the answer to the problem, it's looking for the value of h. The value of h is not going to be negative because it's a length. So we're actually going to say that h is equal to 6.32 feet, because the negative does not work because you wouldn't have a negative length within the problem.